If you checked out a Chromebook during the quarantine, please remember to bring it by May 19th. We hope you've made good use out of it and look forward to seeing you then. Hi families, Dr. Adam here with a quick announcement. You probably noticed that I use a lot of counting pieces and counting chips when I'm explaining math concepts to kids in these videos, just like I do in the classroom. What you're probably thinking is, maybe I'd like some of these, but I don't know where to get them, and even if I do, they seem kind of expensive. Well, for many years, before I taught elementary school, when I was working with much bigger kids, and I wanted to work with my own smaller kids at home, I would use simple arts and craft beads. And these are great because you can get them for really cheap. The dollar store sells bags for, you guessed it, $1, and you can get them at other stores. Now, if you do want to splurge, however, there are some advantages to the sets that we use in the classroom. For one, they measure exactly a centimeter, and they stack 2-dimensionally and 3-dimensionally. These single units also have corresponding 10 rods, hundreds squares, and thousands cubes. If you don't mind spending a little bit more, go to your favorite online website for ordering products and type in Math Manipulative. There you'll see a number of useful products, including the exact type of set that we use in our classrooms. What I really like about these is that they don't just have basic counting blocks representing 1. They also have bars representing 10, squares representing 100, and cubes representing 1,000. All compatible and on scale with each other. Also keep in mind that on Amazon, if you spend at least $25, you get free shipping. And this is $24.99, basically a cent away from $25. So you might want to add a cheap sponge or something like that to your order, just to make the $25 minimum limit. These chips that I use have some advantages too. For one, they measure a standard inch, and connecting them adds inches accordingly. They have colors that you can choose to contrast or match. And they come in this nice convenient container. Whatever you decide on, I hope your family makes the most out of these materials, whether it's because you're spending more time together during the quarantine or after the quarantine when you guys just decide to work on homework together. Now, some kids already respond well to numbers on paper, and that's fine, though it doesn't hurt to have a little bit of extra manipulatives around for illustrative purposes. However, for the kids that aren't responding as well to the written numerals on paper, sometimes this extra visual makes all the difference between struggling and working with ease. And we all want things to be easy for our kids and on our wallet. Did I mention that they're just $1? Thanks for listening. Have a great day. To access your iReady lesson, simply go to myaps.edu and click on the iReady icon. If you haven't already done so, please install the login extension. Once you're in, you'll want to click Math, since that's what we're doing today. And you'll see 2 types of lessons as usual, My Path and Teacher Assigned. Try to do both, but if you only have time for one, try to prioritize the Teacher Assigned lesson. From this point onward, you know the routine. After you're done with that, go to the Student Resources folder and click on the Prodigy Math game. To log in, you'll want to use your Google account, and this is your APS Google account that begins with 9800, not a personal home account. Then, once you're in, you'll be asked whether you're playing from home or school.
Are you playing from home or from school?
You'll want to click Home, choose your world, and then begin your adventure. Hi, it's Dr. Adam here, and today I want to discuss some things that we've gone over in our review in the last few weeks to apply them to word problems. So let's get started. And this word problem comes from iReady. Troy has 18 homework problems to do. Let's just imagine these are all homework problems right here. Each of these is a box with a homework problem in it. He has 3 days to finish the homework. If he does the same number of problems each day, how many problems will he do in a day? Well, basically we got to break this up into 3 days. So let's just grab a chunk here. There's one day, there's another day, there's another day. And let's make sure they all have the same number. It looks like they do, but let's say they didn't. Say we had something like this going on. All we'd have to do is keep on separating and remixing them until they all have the same number. And it looks like if we divided 18 into 3 equal parts, each of those would have 6 units. So, over the course of 3 days, Troy would do 6 homework assignments each day. Day 1, day 2, day 3. All right, here's another one. Your class is having a pizza party. You buy 5 pizzas. Each pizza has 4 slices. Now imagine these are square pizzas like the ones at Chuck E. Cheese, not round pizzas. How many slices is that altogether? Well, here we have our first 4. Our second 4 makes 8, 12, 16, 20. Because 5 times 4 is 20. But you could also say 4 times 5 and just count 5, 10, 15, 20 4 times and you still come up with the same number. And it's easier to skip count by 5 anyway. All right, so Julian is writing a comic book. His story has 143 frames in all. If he wants to put exactly 11 frames on each page, how many pages would he have? Well, one way to do this is to remember that 11 is just 10 and 1. So if we're looking for 143, with our first 11, we're not quite there. With our second 11, we're also not there. Remember that multiplying by 11 just means adding 10 and then adding another 1. So add 10 to 11, you get 21. Add another 1, you get 22. 32, 33. 43, 44. 54, 55. 65, 66. 76, 77. 87, 88. 98, 99. 109, 110. 120, 121. 131, 132. 142, 143. And we've reached our goal. We now have 143. How many 11s did we need to get there, though? 1 11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We needed 13 sets of 11. So that would be 13 pages of the comic book, each with 11 frames on it. Probably not the most exciting way to organize a comic book, but we should be grateful that the math problem is making it easier for us by making it a little bit less interesting. Okay, how about this? Jesse's white wall is 13 feet long. He wants to cover the top of the wall with posters. His posters are 2 feet wide each. How many posters can he fit on the wall? And how much white space is left over? Well, it seems to me that we could fit 1, 2, 3, 4, 5, 6 posters on there. And there would still be 1 foot left over. Okay, here we're going to be looking at remainders. So keep that leftover in mind. That's often referred to as a remainder, and it's a concept you'll be dealing with quite a bit in math over the coming years. So on that note, more remainders. Marion baked bread, cookies, and pastries one Saturday at home for her family and friends this holiday season. She made 47 gingerbread cookies, which she will distribute equally in tiny glass jars. If each jar is to contain 6 cookies each, how many cookies will not be placed in a jar? Well, let's start filling up jars. Here's our first jar of 6. Our second jar makes 12. Our next jar makes 18. Our next jar makes 24. Our next jar makes 30. Our next jar makes 36. Our next jar makes 42. And our next jar should make 48. But we can't go to 48, we can only go to 47. So the way Marion is doing it is each of these cookie jars has exactly 6, or there's no jar at all, which means 5 are left over. There is a remainder of 5. Now in real life, you'd say just put the 5 in a jar and hope that your least favorite family member or friend doesn't notice that they got 1 cookie less than everyone else. But according to the math problem, each jar must have exactly 6 or bust. So this is called a remainder. This does not go in any of the cookie jars. And there's our answer. Let's keep going with Marion's story. She also prepared 59 croissants, which she plans on distributing to her 8 neighbors. Now, since we already know how many neighbors this is going to, let's go ahead and just prepare the first one for each neighbor to start out with. Then we'll take the rest of the 59 croissants and just try to distribute them as evenly as possible. All right, so it looks like each of these 8 neighbors is going to get 1, 2, 3, 4, 5, 6, 7 croissants, and there will be 3 croissants left over. Now, why not just add on 1 extra croissant for like her best 3 friends? because that's not the way the math problem wants us to do it. It wants us to keep track of the ones that don't fit and call that a remainder. In this case, a remainder of 3. And there you have the division concept of remainders, but put into a somewhat plausible real-life situation by a word problem. All right, let's look at some fraction problems. Jilly and Luke went to the school library one fine morning. They planned to read books that day and borrow books to read during the winter. And 5-word problems follow, which means that this is clearly a more drawn-out, interesting story. All right, of the 10 books on fairy tales, Jilly borrowed 3. So what fraction of the books did she borrow? Let's keep in mind that the whole of the collection is made of 10 parts. And so each of these books represents 1/10 of the collection. But she borrowed 3 of them. So that is not 1/10 of the collection, but 3/10 of the collection. Now, out of 15 books on underwater life that Jilly found, she brought 7 to the table. So what fraction is that? Well, we already know that the whole number is 15, and 7 of that would thus be 7/15. Now, we know that Jilly went to the library with Luke, and we've been talking about Jilly this whole time and ignoring Luke. But let's look at Luke's story. He saw 9 books about the solar system and its 9 planets. These were thick books, so he thought 2 of these would be enough. What fraction of the solar system books did he borrow? Well, we have a whole of 9, and this is 2 of those 9ths, so 2/9. Now there are 20 books on land animals and 4 books about sea animals. Now, we don't know how he broke these up, but we do know that he borrowed 7 in total. So, what fraction of the books on animals did Luke borrow? But we know he borrowed 7 books. So which fraction of the books did he borrow? Well, the whole 24 is the whole, and he borrowed 7 out of that, so 7/24 is the fraction. Now, Jilly and Luke found a book together on Greek mythology, and it had 120 pages. Now, out of this whole of 120, they read 40 together. So that's 40 120ths. A little trick, instead of saying 40 out of 120, you can reimagine all of these tens as ones. And you can basically say 4 out of a total of 12. And it means the same thing as saying 40 out of a total of 120.
Okay, so that's the end of the video. Like and subscribe.